Don't forget to subscribe, like, comment, and share this video with your classmates.
Hey everyone, get ready for an adventure. Have you ever thought about this? How did people sail across huge oceans without, phones or GPS? Well, our story today goes way, way back to a stormy night in ancient India with some super brave sailors heading out into the unknown. So, picture this. No Google Maps, right? These sailors just had the stars to guide them. As long as they could see the stars, they were good to go. But one night, boom, the sky just turned pitch black. A monster storm rolls in, and just like that, the stars were gone. So the stars are gone. They are totally lost. ROBO-RON, what would you do?
Easy. I'll just ask my internal navigator. Hey, RoboNet, find me the fastest route to Calicut Port.
ROBO-RON? I'm pretty sure they didn't have RoboNet on those old ships. Yeah, they were in some serious trouble. Well, now, my little explorers, those sailors, they had a secret. They used something that felt just like pure magic, a magnetic compass. A magnetic compass? Whoa, okay, that is it. We have to figure out how these amazing gadgets work. To the lab! All right, time to get to the bottom of this whole magnet mystery. Welcome to my super high-tech lab, which is also my bedroom. For our first experiment, we're going to find out what magnets are actually into. You ready, ROBO-RON? Captain Magnetron reporting for duty. My circuits are buzzing with pure excitement. So check out my desk. I've got a bunch of random stuff here. A wooden pencil, a plastic spoon, an iron nail. Let's see what happens when we bring in the magnet. Okay, nothing with the pencil. Nope, the spoon doesn't care either. But, watch this. Bam! It just grabs that iron nail. So, magnets are picky eaters? That is the perfect way to put it. They only eat certain things, these special magnetic materials like iron, nickel, and cobalt. Everything else? It's a no thank you from them. Okay, experiment number 2. We know magnets have this, invisible power. But where's that power the strongest? To find out, we're gonna sprinkle these tiny bits of iron, they're called iron filings, all over a magnet. Oh, this is gonna look so cool. Whoa, check this out. See how the iron filings aren't just spread out evenly? They make these incredible fuzzy patterns, and almost all of them are bunched up right at the ends. These special ends are called the magnetic poles. Every single magnet has a north pole and a south pole, and that's where all the magnetic force is packed in. I have a brilliant idea. If we want a piece that's only a north pole, all we have to do is break the magnet in half. It's genius. Nice try, ROBO-RON, but here's the thing. No matter how many times you break a magnet, even into the tiniest little pieces, each new piece will magically have its own north and south pole. You can't separate them. They're a package deal. My genius plan, foiled by physics. Okay, so we know magnets have a north and a south pole, but that leads to a new mystery. What happens if you just let a magnet hang freely, not touching anything? I'm tying a string right around the middle of this bar magnet, and I'm just gonna let it dangle. Let's see what it does. Whoa, would you look at that? I can spin it, I can give it a little nudge, but no matter what I do, it always settles back down, pointing in the exact same direction. It's like some invisible hand is pushing it. Something really, really big must be pulling on it, right? And that huge, invisible something is planet Earth. That's the big secret. Our whole planet is basically one giant magnet. Alert! My sensors are detecting that we are standing on a giant magnet. Is that correct? You got it. And get this, it's totally mind-blowing. You know how opposites attract? Well, the north pole of your compass needle points to Earth's geographic north pole, which means that deep inside the Earth, our north pole is actually a magnetic south pole. Isn't that wild? And the coolest part? You can totally make your own compass at home. It's super easy. All you do is take a regular sewing needle and rub it on a magnet, always going in the same direction, maybe 30 or 40 times. This magnetizes the needle. Then, just carefully poke it through a little piece of cork, float that whole thing in a bowl of water, and ta-da! Your homemade compass will slowly turn and point north. I shall name you Captain Floaty. Ha! Congrats, ROBO-RON. You know, your Captain Floaty is actually a lot like a real ancient tool. Sailors in India used to have this fish-shaped magnet floating in a bowl of oil, and they called it a Matsya Yantra. It helped them find their way. Okay, time for the next big rule of magnetism. What happens when you bring one magnet near another magnet? Ooh, are they going to be friends or enemies? Let's begin Operation Magnet Matchmaker. This is probably the most important rule in the whole magnet universe. When you bring opposite poles close together, like a north and a south, they just snap together. That's attraction. But if you try to push two of the same poles together, like two norths or two souths, you can actually feel them pushing each other away. They repel. It's like there's an invisible force field between them.
Get away from me, Northie. Your energy is just too similar to mine. Exactly, ROBO-RON. Just remember the golden rule. Opposites attract and likes repel.
All right, we've pretty much covered the basics. So now it's time for the really cool stuff. Let's check out some magnet magic, and then we'll wrap up with how to be a good and responsible magnet owner. Okay, last mind-bending question for today. Can a magnet's power travel through solid stuff? I'm gonna put a paper clip right here on my wooden table. And now I'm gonna move a strong magnet underneath the table. Okay, watch this. Look, the paper clip is moving. The magnetic force, it went right through the table? That's like a ghost or a superhero. Exactly. Magnetic fields can pass right through things that aren't magnetic, like wood, plastic, even your hand.
Now that you're all magnet experts, welcome to the Magnet Mania Fair. Step right up, step right up. Try your hand at the amazing floating paperclip. Witness the incredible magnetic car race, where the cars push each other without even touching. You can build a long chain of paper clips that just hang from a magnet, or guide a little marble through a maze from underneath a piece of cardboard. It all looks like magic, but remember, it's pure science.
Hey there, Mr. Magnet here. Listen, to keep my awesome powers, please don't drop me, don't heat me up, and definitely don't hit me with a hammer. It really messes with my magnetism. He's right. Magnets are strong, but they're not indestructible. If you're too rough with them, they can get weaker. And the best way to store them is in pairs, with their opposite poles touching, just like you see here. And all of this science brings us right back to our sailors, lost out there in that big storm. Because they understood the magic of magnets, they had their compass. And with that compass always pointing north, they could steer their ship through the giant waves and dark clouds and find their way all the way back home, safe and sound. You know, it seems like you discovered so much more than just directions today. Always remember, curiosity is its own special kind of compass. It will always point the way to wonderful new discoveries. And that's really the secret to everything, isn't it? Just like it says, curiosity plus experimenting equals discovery. So never, ever stop wondering and never stop trying to find the answers. Unless you're me and homework, we always repel. Oh, ROBO-RON, thanks so much for joining our magnetic adventure, everyone. We'll see you next time.